Hi, in this video what we're going to do is we're going to look at how to identify the new functional groups to level 3 chemistry. This is assuming you've already taken level 2 organic chemistry. This is particularly focused on NCEA Achievement Standard 91391, and the very first thing we're going to do is look at some functional groups. So on the left hand side you can see we've got some functional groups, some that we saw in level 2 but a lot that we haven't. So the very first functional group, the shorthand version of it here is, I put a line on the left hand side, that means that this is just bonded to another carbon, but I've written it COOH, and that's the shorthand way for showing this functional group here, which is a carboxylic acid functional group. The next type of functional group, which may be new to you, is called an acyl chloride. Now the shorthand way of writing this is COCl. It has a carbon double bond O and then connected to a chlorine group. The third one down here is what's called an amide, and this is actually a primary amide. We can actually get primary or tertiary amides. Secondary or tertiary amides. Now this has the shorthand here of CONH2. We're looking for this when we have a condensed formula, or when we have the expanded formula, we're looking for a carbon with a double bond oxygen, NH2. The next one down we may have recognized from last year when we reacted a carbonate with a base. So when we reacted a carboxylic acid with a base, it produces a carboxylate. Carboxylate is just a carboxylic acid once it has donated its proton, so once it's lost a hydrogen and a plus, it becomes this C double bond O, O minus. And then we have this next one down here is an aldehydes and ketones. Now they're very similar, and what they are is, so just whenever a carbon has a double bond oxygen, it is either going to be an aldehyde or a ketone. It is an aldehyde if it is on the end of a chain of a molecule, and it is a ketone if it is if that carbon that has a double bond oxygen is bonded to two other carbons. The next one we have is what's called an ester. Now an ester looks a wee bit like a ketone, but if you look carefully down here you can see that though it has a C double bond O, it is attached to an oxygen, and that oxygen is then bonded to some more carbons on the right, and the carbon on the left is bonded to more carbons on the left. The last one here is just what we would call a secondary amide, and this secondary amide is still has a carbon double bond oxygen joined to a nitrogen, but the nitrogen, instead of having two hydrogens bound to it, is also bound to a carbon. Okay, so these are the new functional groups that we need to be familiar with and know. So let's just have a look and see if we can identify them. We've got 6 molecules here. So just pause the video, circle, and see if you can name the correct functional groups. So here are the correct functional groups. The first one is this carbon double bond O, NH2. This is called an amide, more precisely a primary amide. The second functional group we have here is called acyl chloride, or an acid chloride, and there it is there. The next one we have is this carbon double bond oxygen joined to an O in the middle of a molecule. This is called an ester. So this is an ester functional group. Now if we go and look at the next one to the right here, we have a carbon double bond oxygen joined to a nitrogen, so it's an amide, but notice how this nitrogen is not bonded to two hydrogens, it's bonded to a carbon on its second bond, so it's actually called a secondary amide. If we go down to the next molecule, we have a carbon double bond oxygen in the middle of the chain of carbons. In this case, this is called a ketone, but the same functional group on the end of a chain of carbons is called an aldehyde. And even though ketones and aldehydes have the same functional group, it's mostly the same. Because one is at the end and the other isn't, they are different groups. So let's look at how we might name some of these molecules. Okay, so if we use 6 simple rules to name molecules, and we have on the right hand side a table of all the prefixes and suffixes for the different functional groups. These are including the ones that you learnt in level 2 and the ones that you've just been introduced in level 3. So the 6 things that we need to be able to do is first identify the parent chain, or the longest chain of carbons that has the functional group that's most important in it. That's going to give us our parent name. Then we want to look at the longest chain and see what is the functional group in the longest chain that might change the suffix on the parent name, and we'll go over that in a second. Once we've done that, we're looking for 3, what are the other functional groups that we need to name by writing prefixes. And then when we get to 4, we're going to make sure that we number the functional groups correctly so that they get the lowest possible number. And then 5, whenever we have multiple of ones, we write di, tri, and tetra. And 6, lastly, if we have multiple prefixes, make sure we put them in alphabetical order. Okay, so using these 6 rules, let's look at this first molecule. This first molecule has 1, 2, 3, 4, 5 carbons in its longest chain, or the chain with the ketone group in it here. So it's going to have, the parent name is going to have the prefix pent. It has 2 different functional groups. It's got this ketone functional group here, and it has this halogen or this bromo functional group here. So because it has this ketone functional group, and we go over to find here, this is where the ketones are, a carbon O joined, or carbon O, it's joined to a carbon here, joined to a carbon here. It has the suffix anone. So we now have pent anone, but we have to do one more thing. We need to say exactly where it is this carbon double bond is, double bond oxygen. So we're going to number, and we're going to see that it's off the second carbon. So the parent part of this name, the last part of this name, is going to be pent and 2-one, because the ketone group comes off the second carbon. And this is going to have preference because this has higher priority, this functional group, than halogens. Halogen have the lowest priority above the methyl or the alcohol groups. Okay, so this is the parent name, but now I also need to identify the bromo functional group coming off. It's coming off number 4, so this is going to be called 4-bromo-pentan 2-one. And let's look at the next molecule. So the next molecule has in its longest chain 4 carbons, 1, 2, 3, 4. We can see that the major functional group, the highest priority one in its functional chain, and its longest chain, is this acyl chloride group. And the acyl chloride group has the suffix anoyl chloride, but there's 4 carbons, so it's called but-anoyl chloride. Now, for any of these functional groups, double bond oxygen functional groups that are the end of the molecule, we always start the number from them, so their number is always 1, and because their number is always number 1 in the numbering, we never write it. So in this case, we're just going to write butanoyl chloride. That's the parent name, but we have this substituent coming off, and it's coming off the 1, 2, 3, the third carbon, because remember we started 1, the most important, the first number is at the most important functional group. So we have 3-methyl butanoyl chloride. Okay, let's have a look at the last one here. The last one is 1, 2, 3, 3 carbons. It's going to be prop. It has the functional group here, which is actually an aldehyde functional group. It's the COH, okay, and it has the suffix anal. So this is going to be called propanal. Now, I don't need to say, remember, the number of it again, because an aldehyde, the double bond must always come off the end. So by being an aldehyde, it is actually the carbon that the double bond is joined to is 1, so we don't have to give its number. So it's just called propanal. Okay, and that's these ones numbered. Okay, let's have a look at some more compounds that we're going to name. This is looking at level 2 level 3 organic chemistry naming. So we've got 3 molecules here. Let's just see exactly what they are. Now we can see that in the first molecule we actually have It's interesting. If we look in the molecule, we can see that in the middle of the molecule, there's the carbon double bond oxygen joined to an oxygen, but then this oxygen has joined to it this ethyl group, or a CH2, a CH3. Okay. On the other side, we have 4 carbons joined to the carbon double bond oxygen, oxygen. So this actually has 2 separate parts to the name. And the part that has the carbon double bond oxygen, oxygen is going to have the suffix NO8. Okay? And this is actually an ester, and there are 4 carbons in the side of this molecule that has the carbon double bond oxygen attached. So this is going to be called butanoate. So that's the second part of the name, and it includes this functional group. Now what I've told you here is the whole left-hand side of this molecule, but I've excluded this group on the right-hand side, this part that I've highlighted in the blue oval. So this is actually an ethyl group. It's an alkyl group that has 2 carbons. It's an ethyl group. So this is actually just going to be called, now because this ethyl group is attached to the oxygen doesn't have an associated number, so we're just going to write that this is ethyl butanoate. And this is how we name an ester. Now take here when we write an ester's name, the ethyl and the butanoate actually have a space between the 2 names. There is a front part of the name, that's the alkyl group, and the end part of the name, and that's the carbon chain with the carbon double bond O bonded to oxygen. So let's have a look at the next one. The next one here, we can see that the side that has the carbon double bond oxygen in it only has 2 carbons. So it's still going to be called NO8 again, okay? So, but it is going to be called ethanoate, okay? Now, and when we talk about the functional group for an ester, the R represents any chain of carbon and hydrogen molecules. In this case, it's 3 long. In the previous one, it was 2 long. So it's this chain here, and this is, remember, is going to give the first part of the name, but the NO8 part, the ethanoate, is going to give the second part of the name. And so the first part of the name here is 1, 2, 3. It's going to be propyl for the first part of the name, so this is now called propyl ethanoate. And the last molecule we have here on in this video is this one here that has only 2 carbons. Now notice, however, it has 2 carbons, but so it's going to be eth something, but it has this functional group here. And if we look this functional group up here, carbon, oxygen, NO2, it's an enamide, right? Now because it has this carbon double bond oxygen at the end of a molecule, it is always number 1, so we don't have to give the number for it. So this is going to be called ethanamide, right? Ethanamide. However, we also have this OH group here. Now the OH group has both, you could either use a suffix or a prefix to name it, but because we've already got a different suffix, the enamide, we can't put the enol at the end, so we have to use its prefix. So we're now going to call this hydroxy. So we would normally call it an alcohol if it was just by itself, enol, but here we're going to call it hydroxy and put it as a prefix at the start, and we have to give its number. So we have ethanamide for the enamide part of the molecule, and we have the hydroxy coming off the second carbon, so this is 2-hydroxyethanamide. And this is how we name more complex organic molecules.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.